Hello, and welcome to your notes on 2.2 direct variation. Here's a little bit of vocabulary for you. Two variables, x and y, show direct variation provided that y equals kx and k does not equal 0. The number k is called the constant of variation. So that constant cannot equal 0, because if it did, then you wouldn't have anything to vary. It would just be 0. And then we say y varies directly with x. One thing I want to point out here is you already see that y equals kx. We're going to be doing a lot with that constant of variation. So I want to know, what does that actually mean, aside from it does not equal 0? Well, if I solve for it, so I'll divide both sides by x, then I'll find that k is equal to y over x. Always, 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 always. That's going to help us out for our first set of problems. For each function, determine whether y varies directly with x. If so, find the constant of variation. So when I'm looking at this, we have an xy table, we have x values and we have our y values, and they are telling me, or they're asking me, if y varies directly with x. So if it does, I already know that k will have to equal y over x as a constant of variation. That means it constantly equals that. So let's look at what we have for the first value. When y equals 2, we'll put 2 over x, which is 3. Okay, 2/3. Let's see if that works constantly. So the next one would be 4, because that's the y value, over 6. Well, that reduces to 2/3. So far, I've got 2 checks on my way. And the next one is going to be 6 over 9, which also reduces to 2/3. So is it a constant of variation? Does that equal that constantly? Yes. So yes, it varies directly. And then your constant of variation is equal to 2/3. Do the same check for part B. Pause for a moment if you would please, and then tell me what you get. Okay, so for that one I said yes, and my constant of variation was -2, because when I divided each of these, I found that it was -2 each and every time. You should make sure that you check every single value, because it could just be that for the last one it doesn't work. Okay, our next set of direction, determine whether y varies directly with x. If so, find the constant of variation. So if it does, y equals k times x. So let's get y by itself. So I'm going to subtract 2x and subtract 2x. And I have y is equal to -2x plus 3. Well, what do you think? Constant of variation, or direct variation, says y equals kx. It doesn't say plus anything, and it doesn't say minus anything. So this is a no. It is not. Looking at part B, y is already isolated. And so looking at this one, it's not plus anything, it's not minusing anything, and it's just a number times the variable x. So I'm going to say yes. And then it says, if so, find the constant of variation. So your constant of variation is equal to -3. Notice here, guys, I'm taking the time on purpose to write those words out, because I don't want you to just say k equals blah, 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 because it could be a instead. So it's k equals, you're going to say the words constant of variation equals -3. All right, your next set. Really quickly here. Given y varies directly with x. That's the given part. What do they want from me? Well, if y equals 6 when x equals 2, find x when y equals 12. So the first thing I want to show you is how to write your direct variation equation. So we already know that y equals kx. So to find my equation, I'm going to use what I know. That's the if part of this. So instead of y, I'm going to write 6 equals, instead of x, I'm going to write 2. So 6 equals k times 2. Well, that means k, my constant of variation, is equal to 3. So my formula is y equals 3 times x. If that's all they wanted, if they just said write an equation that relates x and y, then I can just say y equals 3x. But they want to know what's the value of x when y equals 12. So I'm going to use my formula and plug in 12 for y equals 3 times x, which is what I'm trying to find. Dividing both sides by 3, I find that x is equal to 4. That's my solution. If you could please, one more time, press pause and then try the next one on your own. So go ahead and check your work with my work. Plugging in, I got y equals 5/3 x, and then when I plugged in the x in order to find the y, I found that y was equal to 10. Okay, so for our next example, they are asking us to write and graph a direct variation equation that passes through -1, 3. So one thing I forgot to mention up top was direct variation equations always go through the origin. Always, always, always. It's because it's not plus anything and not minus anything, so there's no shift. So they will always go through the point 0, 0 automatically. Now they also tell me that it goes through the point -1, 3. So I'm going to go ahead and graph that as well. And then I'm going to connect my dots using a straight edge, of course, which I don't have, but you're going to have to trust me there. There you go. And that's your equation. Now, I would love to label it. In order to label it, I would like to find my equation first. So here's what I have. I have an x value and I have a y value, just like I had before, like right over here. So if I know that y is equal to kx, and I know that the y value is 3 and that the k is k, we don't know it, and the x is -1, then if I solve this, I find that k is equal to -3. So my equation is y equals -3x, and you can label your line accordingly. Y equals -3x. All right, and that's your lesson on direct variation. Thank you so much.